Hey guys, welcome back. We are picking up right where we left off on the mining pool REST API, which again looks like this. And today, we're going to actually be linking up the database to the back end of our API so that we can actually persist the different wallets and miners that we're creating, and we can have these objects be stored and returned back to us on the API. So, first thing we're going to do to set this up is we're going to get a new cargo toml going here. So I'm just going to copy these new ones in here. And we're going to add a few new imports, mainly around the Diesel ORM. Now, what an ORM is basically, and what Diesel is basically a library that allows you to convert Rust structs, so the objects represented by structs, into database table records. So if you have a table with the same fields as a struct, you can convert from records to objects, simple as that. And we've already laid the groundwork for that with our objects here, these DAO objects. That's exactly what these are designed to do. And that's why they look like this. So it's worth mentioning really quickly before we get into the database stuff that these blue fields here in the JSON bodies, those are actually going to come, like I said in the last video, from objects in the other table. And that's done by what's called a join. Now, a join, you don't have to worry about exactly how it works, but basically the relationship between these two fields, right? Since the miner has an address that corresponds to a wallet, they can get data from each other. So in the case of our API, all four of these fields are going to actually come from the miners that are included in a wallet. So any miners that have this address. And in the case of the miner, the club name is going to come from whatever wallet holds this address. So just an interesting relationship to think about. We're going to see how that plays out in our Rust app going forward. So we see these objects here. We know what we created them for. But now it's time to go ahead and activate them. So first we're going to activate them by adding the annotation that's going to allow them to actually be written and read from the database. And that looks like this. There's going to be two of them. So the first one is going to be this derive queryable insertable. And then the table name, and this one's going to be miners. And we're obviously going to have one, of course, for our wallets as well. So I'll go ahead and add that. And this is going to be yelling at us a little bit because we have to update our imports. I'm just going to go ahead and add all the imports in here that we're going to be using. But don't worry if you see some ones you don't know or that you haven't seen before. And even if we see all these yellow underlines, we will get to them. So, and I'll just add them to wallet as well. As we go here, the cusp of this video, what we're going to do is cover the methods that are going to allow us to write this stuff and pull it from the database. Now, the best way to do this is if you want to go to Diesel's Getting Started guide. It looks like this. Personally, I felt like it was only helpful until about here. Maybe here. And then I started to kind of find resources elsewhere. But I'm going to give you a quick run through of how to set up Diesel if you haven't already. Now, just a quick disclaimer. We are going to do the Postgres version. It has features for different databases. We're going to do Postgres. And I've already got Postgres installed on my machine. And I'm using WSL2, so I have the Linux version. Now, you want to make sure Postgres is running first. So if you're on Windows, go make sure the server's running. If you're on any kind of Linux distro, this is probably going to be the command that you'll have. And we can start ours up here. And now what we're going to do is we're going to do cargo install Diesel CLI. And then we're going to add this flag for no default features. And the only feature we are going to include is going to be Postgres. And now I've already got it installed, so that was pretty quick, but this may take a while for you. And just a disclaimer too, there are some things that might come up when this is running, when you're trying to install this. It might yell at you about certain libraries missing or whatever. You really just want to make sure you have either PostgreSQL, the PostgreSQL development tools, or libql, depending on what Linux distro you're on. But anyway, so once you've done that, you're going to want to type this Diesel setup. And now immediately what we get is we get yelled at about the database URL argument must be passed or the environment variable must be set. Now I did some digging on this. And personally, there's a couple different workarounds that I've seen. A lot of people like to use .env, .env, but that just wouldn't work for me. So the only way I felt that this actually worked was by literally setting the database URL. So I'm just going to go in and set it to my WSL2 Postgres path here. And so now that that is a successful database URL environment variable, you can see it's accessible from where we're at. Now we can run Diesel commands because Diesel needs to know what database to point to. So no output from Diesel setup, but what that does is it actually creates a few files for you that Diesel's going to use. So the first one is going to be Diesel toml. And it's saying, okay, we're going to be pointing at this source schema file, which hasn't been created yet, but we'll see it in a sec. And now it's also going to create this migrations folder. And in here is up and down SQL. Now, these particular files you don't have to worry about, but they have some gobbledygook that Diesel's going to use to do different operations. But what we want to do is create our own migration. So we're going to do Diesel migration generate, and I'm just going to keep with the program here and call it the same thing as our app, mining pool API. And you can see that it created those migrations. And now if we go into not the all zeros, but the one that has like a date, which is going to be now, that's going to have its own up and down SQL. And you can see here, your SQL goes here. And all these really are going to do is when you use the Diesel CLI, they're going to be able to go in and create your database tables and the associated, fields and data types and all that for you before your application even boots up. And this is for use of like stuff that what we're doing right now, like if we're going to have a database where we want to just like initialize some tables and stuff, and we're really running this in like development, this is what it's really good for. Ideally in production, like your database tables will exist already. But how to use these migrations is very simple. If you've ever written SQL files before, this will look pretty familiar. But to save you guys the pain of watching me type it, I'm going to paste these in here. But you can see what's going on here is we have two SQL commands here that are just going to go ahead and create the tables that we want. And as you can see, these tables and these fields directly correspond to what we have in our DAO objects, both in our diagram and in our program. So that's really cool. And that's all that up.sql is going to do. In down.sql, as you can probably infer from the name of the file, all we're going to do is the reverse operation and drop those tables. And now in our situation, since miners relates to wallets, you need to drop miners first. I've gotten some errors about that. So now that we've populated these files and Diesel knows what we want done when we run a migration, we can go ahead back to the CLI and do Diesel migration run. And that right there just created those tables in your database. And it also created this schema.rs file. And we'll talk about this in 1 second. The last thing I want to show you in the Diesel CLI is just make sure you do this migration redo after you do run. And that's just going to do up and down. It'll do down first and then up. And that's so you know that both are working correctly. If you get no errors, you're good. So going back to schema.rs, what is this thing? Well, take a look here. All these really are just macros that our Rust program is going to be able to use. And it's going to create these tables within macros, which is kind of wild. And you don't need to understand exactly what's happening here. But as we build these database methods and as we work with our database transactionally, you'll see exactly what these things do. And they're actually super cool. But all right, so let's close all these out. We ran Diesel migration run, so our tables are in there. We're good to go. Now, all we have to do to get this thing online with a database is, like we said in the last video, start writing some methods that are going to allow us to transact with the DB. So there are going to be some changes to the root, and we'll go and make those last. But we're actually going to start by going back to our drawing real quick. And now let's take a look at the fact that we have these blue fields here. So we talked about what these do. But one thing we're going to need to do is we're going to have a slick way to convert between these two data types, right? Like we're going to have to go define the functions that are going to allow us to flop from the DAO version to the REST version. So let's do that, and we'll reference that diagram again. We'll start with wallet, and we'll go up to the wallet object. And now let's activate a conversion from a wallet to a wallet DAO. And that's just going to be an implementation. And I'm also going to be changing this from a string to a UUID. And that's just going to be a unique identifier that's easily parsable into string. So up here, that's what we're going to be converting this thing into. Now you can see that easily this is just flipped right into wallet DAO with these two values that come right from it. And we're going to go down and do the one for wallet DAO to wallet. Now here, the tricky thing is to go from DAO to wallet. It was easy to go from wallet to DAO, right? Because we had these fields already. So we didn't need to add anything to our function. But to go in the reverse direction, we have to get all of these values, right? And from our diagram, those come from the join. Those come from the information from other tables. So we're going to have to go fetch this information before we can convert from a DAO into a REST object. But the nice thing for us is we can get all three of these data points from this one. So like if we have the list of all the miners, we can count it. We can get the total shares mined and the total hash rate, no problem. So all we're going to need to do to create this object is we're going to need to pass in the workers online. And that's going to be a vector of miners. This is obviously going to return a wallet. And I'm just going to go ahead and copy in what that's going to look like. So with the exception of the workers online fields, again, we're using self-references. And then workers online is just the vector of workers online that we're presumably going to have when we run this. And from that vector, we can actually see here that we're doing these iteration mappings. And we're just mapping it to the value of the hash rate and summing it, and the value of the shares mined and summing it. And like I said, we're just taking the length here. So that's how we'll do that. But still kind of strange because we're going to need to get this value ahead of time. And the reason I wrote it like this is because this is going to be a database operation to get this. And this right here isn't going to be necessarily asynchronous. So we wanted to have this represented standalone. But we will go ahead and get this value and pipe it in. But all right, so let's flip over to miner. And let's go ahead and write those exact same methods for miner. So we'll start with the miner object here. And we'll go ahead and do implement miner. And that's going to be it. Again, nice and easy. We have more self-references. I'm going to make these UUIDs like I did with the wallet, and you'll see why. It just helps with database work to make sure these are all unique. So again, all self-referencing. This is pretty easy to convert from the miner to the miner DAO. But now again, going in the reverse direction, we've got this club name that comes up again as something we need to fetch using a database method. So just like we did with the wallet, we're going to go ahead and implement for miner DAO the conversion to a miner. And just like we saw before, that's going to take the club name as a string. So I know that can be kind of confusing, but I promise it'll make more sense in a minute. But now we've got methods to go from one to the other. And on both objects, our requirements to go from DAO to REST object require additional data. So just remember that, keep in the back of your head. Now let's go forward with the miners first. So our first endpoint is going to be list all miners. We know this. So let's go ahead and create a new function that's going to just be fetch all miners. And now each of these are going to take a reference to this DB pooled connection object here. And we'll talk about this later on, but essentially what's happening is any function that we write that's going to operate with the database, it needs to be passed in this connection pool because it needs to be directed by Actix to talk to the database. And since Actix is all asynchronous and these functions are not asynchronous, we have to make sure that our database isn't going to like have errors, like we can't just write to something twice at the same time. Like there has to be locking going on, and like we have to have order of operations there. So that's all that this is really doing, and it'll make more sense as we go. But anyway, so we're going to return that vector of the miner type. And in here, we're going to actually use create schema miners DSL all. And now that's pretty neat. We can actually use a use method or a use keyword inside a function. And as you might have guessed, that just makes this use key valid only for the scope of this function. And now if you notice, we're also using schema. So create schema. Well, that's obviously the schema file that we have here, right? So what's miners? Well, that's just this table right here. And this macro has converted this table into the contents of your database based on the functions that you run on it. And you'll see what I mean. So if we want to use this, we can go ahead and just do miners.load, and let's load them as miner DAOs and just pass in that connection there. But now this is going to be a result. So what we want to do is actually match on that. And on this match, we're going to dictate what kind of vector we get. So if it's okay, we're just going to let that result come through. And that result, we're going to put into an iterator. And we're going to map it. And we're going to map each miner into what would be the miner, or each miner DAO, into what would be a miner. But here's the tricky part, right? Oh, and when we're done, by the way, we'll just collect it into a vec of miner. And if it's an error, we will just return, I don't know, like an empty vector per se, right? Why not? But so back up here in our map statement, what's the issue we have here? We already wrote a method to convert from miner DAO into miner, didn't we? It's right here. But what do we need? We need the club name first. So how do we get the club name from another database table that's not part of this? Well, we're going to need a new function. So we're going to have to actually query the database for information about the wallets table. And so we're going to do get club name, and we'll pass it in an address, which is just going to be a UUID. And again, that connection reference to the DB pooled connection there. And this will just return a string. It's just going to be the name of that club. And now, here's where things get kind of interesting. So we could write the logic here to look up a wallet. But why would we do that when we're going to go write that anyway? Right? Like we're going to literally write this function here as we go implement the methods for the database for the wallet. So assuming it needs to look like this, where we've got an address and a database connection reference, then we can just match on that. And if we get the response that we're looking for, some matched wallet, then we're going to go over and do matched wallet dot club name. And if we get none, then we're going to respond with club name not found. And we're going to do that to string. So that covers our option return type. Now, here's the issue. We didn't write this method yet, right? So before we go too far, we want to make sure that this is going to actually return the way we think it's going to. But the implementation that we would be looking for down here is we're just going to say let club name equal get club name. And then as you can see, our address is just going to be m.address. And our connection is just going to be that con value that we passed in. And now that that's done, we have the club name there. It's just going to be m.toMiner club name. And since we wrote this to return a string either way, no matter what, if we get some or none, this is totally valid without any kind of option handling in here. So that's good. Looks pretty clean. And this is our implementation to get all the miners. That's how we get the club name from any wallet that each miner is linked to. So we already wrote this out. Let's go into our wallet file and let's write that function now so we don't forget. So we're just going to do pub function. Fetch wallet by ID. And we said it's going to get an address of type UUID, right? And we're also going to use that con db pooled connection again. We're going to see that a lot. And we handled it as an option in the previous example over in that other file over there in Miner. So that's how we're going to handle it here. And once we've done that, again, we're going to use this schema crate thingamajig. But instead, we're going to use the wallet schema. And with that, we're going to match on wallets. We're going to filter it this time, where the address is equal to the passed in address. Now take a look. Notice as I write this address word here is not anywhere in the scope of this function. The only one we have is underscore address. That's because this came directly from the schema. And that's exactly what's going on with this right now. It's an actually referenceable object, but it references the contents that could be in this database. So kind of tricky, but it gives you the unique capability to do inline statements like this and do operations in Rust, just typical Rust syntax, without having to worry about like all the underlying SQL. So anyway, let's load that up. It's going to be wallet DAO as a load, pass in the con, and since we're matching that, we want to do something with an OK. And now again, this thing is going to get tricky. So we only want one to come back. So we're going to match on result.first. The reason you have to do a match is because it could be empty, right? So it's an option. Now, if this has some matched wallet in there, here's what we're going to do. Yet another curly bracket. I apologize. We need to handle the conversion from the matched wallet DAO into a wallet object. So how do we do that? Well, we know how to go from DAO to wallet is going to require the workers online. So we can't really proceed without knowing how to get workers online. Just like past here in Miner, where we couldn't go any further without getting the club name, we need to get the workers online first. So what we're going to do again is we're going to write a new function. And this is just going to be get workers online. And we're going to pass in a wallet DAO object, which is just going to be a reference to a wallet DAO. And then con, which is going to be a reference to the DB pooled connection again. And this is going to be a vec of type miner. And now if this is getting confusing to anybody, bear with me. It will make sense in a minute. Again, we're going to use the crate for schemas, this time using miners. And now we're going to run a match on our miners.filter. Just like we did down here where we're filtering, we're going to filter on the address being equal to the wallet DAO dot address. So if those addresses are equal, load it up into miner DAO objects using this connection. And then if it's okay, we're going to do the result. And we'll do into iter dot map m dot toMiner. And we already have the wallet DAO's club name because we're passed in a wallet DAO object. So that to miner conversion is no problem. We've already got a wallet DAO, we've already got the club name, and we can conduct this operation. And again, like I said before, I like to have these on new lines here. So I'm going to drop these down, and we're going to add our final one to collect to a vec of miners. And then, of course, if this is an error, we're going to return an empty vector like we've seen before. Sweet. So now this is in position. And down here, we can complete our implementation now. And we can just say, for mapping this value, for returning a mapped wallet DAO to wallet, we're going to say let workers online equal get workers online, of course. We're going to reference the matched wallet and just pass in conf. And then right below that, we will have some matched wallet dot to wallet, and we will pass in workers online. And that will take care of business for our match case with the OK. And then, of course, if we don't have anything there, we're just going to do none. And then down here, again, if we have an error of any type, we will also do none. So let's recap here now. We did some bouncing around amongst these database functions, but now we have everything we need to convert to and from data types. So we need workers online to convert from wallet DAO to a wallet. Here's get workers online. We need the club name to convert from a miner DAO to a miner. Here's get club name, right? And all of these are set up. So let's pound out the rest of this API. The next thing we're going to need is we're going to need get all wallets. And so that looks exactly the same as our fetch all miners, right? We're just returning an empty vector if there's an error with the database. And other than that, we iterate it and we map it to, instead of a miner, a wallet. So same thing. Now we also need to do get miner by ID. And as you can see, that looks exactly the same as fetch wallet by ID. We've got the same OK error operation going on, the same match, nested match setup. And again, instead of flipping from wallet, we're flipping to miner. Cool. So that takes care of our two retrieving methods. Now let's handle our write methods here. We're going to actually post some new objects into our API. So let's go ahead and build those. We're going to start with the wallet. Let's create a new wallet. And now, as you can see in this one here, we're actually going to be passing in that new wallet request object that we created. So now we're just creating a new wallet here. And as you can see, we're taking the user's input for club name. We're generating a new random UUID, turning it to a string. And then we're just creating these variables here with zeros for now. Because if this is the first time a wallet's being created, there are no miners online for this wallet until we go create them. So this is how a new wallet will get added. Then we just convert it to a wallet DAO so we can write it to the database. And down here, this is where we actually are going to do a match on this Diesel command because it could be, an error. It's going to be a result. We're going to insert into wallets, just referencing that schema object again, values, and it's just going to be that new wallet DAO. Dot execute con. And since we're matching on that, if it's okay, we want to just pass okay, new wallet DAO, dot to wallet, and we'll just have a new vector in there since, like I said, that's going to be empty at first. If it's an error, then we want to just pass that error along. All right. And now that's our create new wallet, and we're going to do the exact same thing over here for miner. And as you can see here, we're doing the same thing we did with the new wallet. We're passing in that new request, that new miner request. And that's, of course, just going to have in here a nickname for the miner as a string. But we also have included this address. And that's because as part of our new miner request, if you remember from the diagram, we're going to need to actually add the address in there as well. So that value is going to play a role as well. So we'll see that defined here. And boom. As you can see, that one's also exactly the same as the new wallet, except this time we're just changing the rules about how we define a new miner. So with the new miner is going to give us the name in a new miner request and also the address of the wallet. Then again, we're going to just create a new UUID for that new object. We take the address and the club name. Club name comes from actually looking up the address right up here. We're going to take the nickname from the user. And then these next two values are just going to be random. So our hash rate, and again, in mega hash per second, that's going to just be a random value between 20 and 100. And then for our shares mined, we'll just have a pre-configured value come from 1 to 40. Nice. So these are all done. We've buttoned up all of our service methods here. And now let's go plug these into the controller. So we're just taking a quick detour over to main because we're going to go ahead and set up our imports and our crate root here just to make life easier as we go and button the rest of this up. So again, we're going to do macro use, and this time our extern crate is going to be Diesel. And then our use statements, I'm going to just copy the new ones in here. We're going to be using the same Actix ones with a few of these Diesel ones, including those pooled connection stuff. And that comes from a library called R2D2. So let's also get our updated modules in here to include the schema. And finally, I'm going to define types for these different database pool objects here. And these will make them easier to reference throughout the rest of our app. And then here's a nice little helper method that will allow us to actually convert from a database pool to a pooled connection. And that's because this is going to be, this result, and then we need an expect and things like that. So we wanted to make sure that this was accessible all throughout the crate, so I put it in main. And now we'll come back here when we button things up to add the database logic to our, Actix boot up here. But all right, so now going to the controllers. If we go into the wallet controller, let's go ahead and string up all of those wallet methods that we wrote. And let's see how nice and easy this is going to look. So let's drop this comment. And we'll do let con equal crate get connection to pool. And now each of these Actix endpoints are going to have this database pool. And that's exactly why we hooked up all the DB pooled connection stuff to each of those endpoints. And that's exactly what it was going to be for. So now we're pulling that in. And I'm just going to quickly update the imports here in our controller as well. So we have those Diesel ones. And now wallets is just going to simply become, instead of an empty vector, it's now just going to be fetch all wallets. And we just pass in that con reference there. And that's it. Look how simple that is. We did all this work and it seemed like a lot. There was a lot of back and forth, but now all we had to do was just press this button here, type this method here into our REST endpoint, and it's that simple. 3 lines, including our HTTP response. Pretty slick, if I say so myself. So, moving right along, since we've been on this video for quite a while, I'm going to copy this into each of these endpoints because we're going to need it in each of these. And then, of course, I'm also going to copy this pool into our header as a parameter. And I'm going to want to put it at the end of all these. And now, here's another interesting little feature here. So, in this situation, we've got everything mapped out, and we know that our wallet is going to be an option wallet, and it's going to be fetch all wallets, or fetch wallet by ID, right? But where's the ID? It's up in our request path. So in order to parse that out, what we need to add is this path variable, and it's going to be of type path, and we're going to put it inside a string tuple type syntax here. And this will allow us to actually parse, and Actix will do this automatically, parse this ID from our request path. And that looks just like this. So instead of option wallet equals none, it's going to be fetch wallet by ID. And this is obviously going to be that reference to con. And I'm going to drop this down here so we got some room to work here. And now we're going to do UUID parse str, and that's going to give us our string that's going to represent the ID. And that's going to be path.00.asstr, and we're going to finally unwrap that. And that will give us the UUID parse of this string ID that the user puts in, and we'll be able to fetch a wallet by ID with that. And then the rest follows suit as we wrote it. Nice. And then on the last one here, pretty straightforward. We're going to also just do that con connection here like we already did. And then our create new wallet, this can actually go bye-bye right now. And what we actually are going to do is we're going to convert this into a match. Okay, and that's our new match statement for our create new wallet. As you can see, I just flipped it over. So we're going to create a new wallet with our service method that we wrote right down here. But then this returns a result. So we wanted to handle that result. And if it's okay, we're going to do that created response like we talked about. If it's not, if there's an error, we also can use that not found response type and have this error creating wallet message pass through. So that strings up all the stuff for wallet. Now let's do miner. So again, I just added our connection pool and our imports and stuff and that conversion method from our create root. And now let's go ahead and do the same thing and change these from empty to live actual endpoints. So this will just be a fetch all miners. Reference to con. Nice and easy. This one's going to be let miner option equal fetch miner by ID. And we'll drop that down to a new line. And then, of course, we'll add that path syntax up here to our path there. And we will be good to go. Now, the last one, of course, is going to be our create new miner. So this is where we're going to combine both things. We're going to combine a new miner request and we're going to combine this path parsing capability to get the ID and the miner request. And so just like with the other one in miners, we've got this match statement going on. And again, we're just doing this response type here. So everything is all done now. We're good to go. Let's go put this thing together in main and fire it up. So we already saw main. We already saw the new imports. We saw R2D2, which is just giving us some database pooling capabilities. And we added our new modules and we made these types for the duration of our entire application. The only thing we didn't do yet is we didn't configure our Actix main to actually be database enabled. So what that looks like is this right here. We're going to let the database URL equal environment var, and we set this earlier when we were messing with Diesel. Database URL expect database URL not found. We'll do detected, right? Detected seems more computery. And then we'll say let manager equal connection manager. And right here, we're just setting up the connection to the database. And that is it, guys. That is it. We just add these configs here to connect to the database. And this thing is ready to rock and roll. So let's go ahead and boot this up and see what happens. All right, so we finally see, after what felt like an eternity, Actix booted up and we're good to go. And let's test this thing out in Postman. So just like we did before, miners, we get a 200, but there's nothing in there yet. So let's go ahead and add, well, we'll start with wallets, right? No wallets. Let's create a new wallet. And it'll just be the Little Miners Club. And there you go. We get this response back to us, 201 created, and this is the actual miner or the club that we just created. And we'll quickly add another one. We'll just do like Big Miners Club. And now let's actually try grabbing this ID that we get kicked back to us. Let's try to look up a wallet by that ID. There's Big Miners Club, the one we just made. Awesome. No workers online yet though, right? So list all miners, list all workers, list all wallets here. We've got both of our wallets in here. Well, let's go create a new miner for that wallet that we just had to the clipboard. So I think it was the Big Miners Club. And we'll just do Joe Miner. And there's that Joe Miner was created for Big Miners Club. And then if we go here and we do list all miners, we got one on there. And if we list all wallets, you can see there's nothing for Little Miners Club. When we scroll down, there it is right there. There's the miner for Big Miners Club. And let's just add one more, right? Just add like Joe Miner 2. Let's have a little fun. And now if we go and hit get wallet again, there's both of our miners in there. List all wallets. There they are again, you know? And so last thing we'll do, we'll test out this endpoint here. We created this miner. It has this ID. And we're expecting to get Joe Miner 2. Let's see if that happens. And that's what we got. And ladies and gentlemen, this is it. We built a REST API in Rust. We got this thing running. We did all the work that we needed to do to make this thing nice and clean and slick. Writing and reading from the DB. You know, you really can't beat it. So well done if you made it this far. Again, as always, the code is on my GitHub. And guys, really quickly, here are the Docker components if you wanted to Dockerize this. This is the Docker file you'd use. And this is Docker ignore, so we don't copy anything we don't want. And then here's Docker compose. This Docker file is specific to Docker compose. As you can see, that database URL environment variable isn't in here. So if you want to run this Docker file separate from Docker compose, you just got to add that. And make sure you can connect to Postgres somewhere. But it's in here, it's in GitHub if you need it. And congratulations, you made your first REST API in Rust.